Okay, so the first slide, the first part is what we've done already. Okay, we've worked on first derivative tests. We've already done that. We did that last week. Okay, first derivative test. First derivative test tells us where the original function was increasing, decreasing, or remaining constant. Okay, that's what the first derivative test will tell us using the slope, right? So today what we're going to start with is the second derivative test. Okay, the second derivative test tells us something different. The second derivative test tells um, it says we will it's supposed to be we will look at functions curvature in terms of con concavity. So second derivative test tells us one of two things. Is it concave up or is it concave down? Okay. So concave up, the easy way to think about something that's concave up is it holds water, right? Something that holds water. So you can see this parabola here, right? It would hold water. Concave down means it spills water. Okay, that's the easy way to think of what is concave up and concave down. Okay, now it's not always that clear because sometimes you'll have a curve like this and you're like, wait, let me draw it a little better than that. Sometimes you'll have a curve like that. And what is that? Is that concave up or concave down? That blue curve there. Would you consider that concave up or concave down? More like that, right? It's like the left side of the parabola, right? But then people will be like, would that spill water though? If you put water in here, if you put water in here, it would spill water, right? And that's right, it will. But it's kind of just an idea of what, if is it cupping? So which way is your cup? Pointed up, or pointed down? That's pretty much how to look at it. Okay? Concave up and concave down. So that's what it tells us about the function. Okay? So how do we tell? Well, luckily it's the same. It works very similar, I should say, as the first derivative test. Okay? Just instead of the first derivative, we look at the second derivative. Okay, so if the second derivative is positive, so if the second derivative here is positive, that means it's going to be concave up. Okay. If the second derivative is negative, it's going to be concave down. And if the second derivative is 0, it's not going to be either. Okay, it's not either concave up or concave down. It's what we call an inflection point. Okay, it's kind of like the in between. Like for first derivative test, when we set the derivative equal to 0, it wasn't increasing or decreasing, right? It was remaining constant, right? It's kind of the same thing. An inflection point is a turn. An inflection point is where the graph changes concavity. Okay? So in other words, to find those points where it changes concavity, we need to find the critical values of the second derivative. So we've found critical values for the first derivative. It's the same thing, you just do it with the second derivative. You set it equal to 0. Okay? So that's what the second derivative tells us. Is it concave up or concave down? So you can kind of see this picture here. Right? Down here, this right here, this curve before the dot, left of the dot, that's concave down, right? After the dot is concave up, right? So that means at the dot, it's an inflection point. It's what we call an inflection point because it changes from one to the other. And then this is the opposite. Concave up here, concave down here, okay? The inflection point changes from one to the other, okay? Just like for the first derivative test, right? If it was decreasing and then went to increasing, where it changed, we called the critical value, right? Or critical number or critical whatever. Critical numbers, critical values, critical points. It's the same thing, but just with concavity. Okay. Here's a couple more pictures of inflection points and what concave up and concave down kind of looks like, because you're going to look at something, you're going to be like I said, the holds water, spills water thing doesn't really work a lot, but it kind of gives you a picture in your head what it looks like. So this could be concave up right here. This could be concave down right here. We just looked at this one right here, and then this is concave up. This one is kind of a little hard to look at, but it's concave up, and this one's concave down. Okay, and then the dot that switches from one to the other is an inflection point. That's what we talk about, inflection points. So you're going to see that a lot. What's an inflection? You're going to see, find the inflection point, or are there inflection points? Well, how do you know if there's an inflection point? How do you show there's an inflection point? You show that it went from, the second derivative went from positive to negative, or from negative to positive. If it switched, then you know there's an inflection point. Okay? Okay, so let's look at the first example. The first example says, determine the intervals where it's concave up, concave down, and if there are any inflection points. Okay? Well, anytime you see concave up and concave down, anytime you see, or inflection points, these guys right here, anytime you see anything about concave up, concave down, or inflection points, your brain should automatically go to second derivative. I need the second derivative. If I don't have it, I need to find it out. Okay, so that's the first thing we're going to do. We got to find the second derivative if we don't have it. Okay, so to find the second derivative, we got to find the first derivative. So the first derivative is 3x squared minus 6x. Okay. Second derivative, find the derivative of the first derivative. 6x minus 6. Okay. Second derivative. Now the first thing we need to do is find the critical values. The critical values will tell us where it switches from concave up to concave down, or vice versa. Okay. So to do that, we're going to set it equal to 0. We've done this before, except with first derivative tests. Okay. Solve it for x. It's linear, so it's only going to have one answer. Okay, divide by 6. And I get x equals 1. That's my critical value. Which is also going to be my inflection point. I know when x equals 1, there's going to be an inflection point there. It's going to change from one to the other. I have no idea what it's going to do, if it's going to change from concave up to down or down to up, but I know it's going to change there. Okay, so I know not only is it a inflection point critical value, but it's also an inflection point. Okay. So luckily, like I said, this one's not that bad because it's the same setup as when we did first derivative test, right? After this, number line. Draw a number line. We put our critical values on there. Well, we only have one, so we put that on there. So we're going to look to see if the second derivative is positive or negative before and after. Okay, so we're going to use the second derivative. We're not going to use the first derivative now. We use the first derivative if we want to tell if it's concave or increasing or decreasing. That's not what we're looking for here. We're looking for concavity. So we're going to use the second derivative. So any number less than 0 or less than 1 you can pick. Any number after 1 you can pick. 0 is an easy number. Okay. So if I plug in 0 to the second derivative, I get negative 6, a negative number. So that means any value I plug in that's to the second derivative that's less than 1 is going to be negative. So that means it's concave down. Before 1, the original function, if I were to graph it, is concave down. And then at 1, it changes. Pick any value after 1. Two. 2 is going to give me a positive 6, positive number. Everywhere there, it's going to be positive. Everywhere after 1, it's going to be positive. Okay, so that means after 1, it changes to concave up. Before 1, it's spilling water. After 1, it's holding water. Okay, so it's going to kind of look like this. And then at 1, it changes. Okay, so we just got to write that down now. Okay, so we got to write intervals, concave up, and concave down. Okay, concave up is where it's positive. It's positive after 1. So from 1 to positive infinity, concave up. Concave down is where it's negative. Negative is from negative infinity up until 1. And then at 1, it switches from one to the other. Okay. And then we also have an inflection point at x equals 1. Okay. So it's very similar to the first derivative test. That's why they call it the second derivative test. It's very similar process to find it, right? It's very similar in the process. It means something different. So don't get them confused, but it's very similar, okay? All right, so try let's see. Let's do this one right here. We'll finish after this one. So to do the next example. Okay, so the second derivative, I got 48x minus 24x squared. Factored that, 2 answers. So I know I'm going to have inflection points at 0 and positive 2. So now I got to plug in numbers less than 0, in between 0 and 2, and greater than 2 to the second derivative. So I'll plug in negative 1. Again, I'm not caring necessarily what value I get. I just want to know if it's going to be positive or negative. Because any number I pick less than 0 is always going to give me the same sign. Okay. So I plug in, let's see, 48 times negative 1 minus 24 times negative 1 squared. Well, I'm going to get negative 48. And then over here, it's just minus 24 because negative 1 squared is 1. So that's going to be a negative. So I know here I'm going to get negative numbers. Okay. So let me plug in something in between. So a positive 1. Well, again, still over here, I'm going to get 24. But over here, I'm going to get 48, which makes positive 24. So that is going to be positive in between. Don't assume that after 2, it's going to be negative. Don't assume there's a pattern, because sometimes there's not a pattern. Okay, actually check it. Let's see. Let's try 3. So 48 times 3 minus 24 times 3 squared. 48 times 3 is 72. No, not 72, bigger than 72. 244. 24 times 9 is what? 260? Perfect. So I know it's going to be a negative number, right? 216. Okay. So negative. See, this is where a lot of you would leave it. A lot of you would say, oh, I'm done. Okay, next problem. I haven't answered the question. Okay. The work is there. You can't assume that the person who's watching it or grading it knows anything about calculus. Okay. So you have to answer the question. Okay. So the question said, where is it concave up? Where is it concave down? And where are the inflection points? Okay. Okay. So concave up, anywhere there's positives, only between 0 and 2. Concave down, before 0 and after 2. Inflection points at x equals 0 and x equals 2. Now I've answered the question. Okay. All right. Okay, so the rest we will finish on Monday. Okay. Nothing new. I'm not going to assign anything new over the weekend. Just if you have any assignments you haven't turned in or haven't submitted, make sure those are done. Don't wait till I grade them. Okay. Because we're nearing November's going to go fast. And then next thing you know, end of the